In class 10 we studied arithmetic progression. Sequence also quite similar with this. So let's find out what do you mean by sequence. And sequence, you can see sequence is what? Sequence means a list of numbers or objects in a specific order. This is very important part. Specific order. You should have some specific order. Okay, whether it can be like descending order or ascending order, or something particular order that should needed. Okay, so the sequence is the list of number or object in a specific orders. Okay, that is called sequence. Now for example, we took one few example. For example, I took this one 3579. Okay, so you can see this is sequence. Okay, sequences what number? Every number is increasing. You can see every number is increasing 3 by 2 2 only, right? 3 plus 2 is 5, 5 plus 2 is 7, then 7 plus 2 is 9, like that. Okay, then uh, next, then you can see next example 4 9 4 9 16 25. Can anyone tell me, is this a sequence? Is this a sequence? Is it following any particular order, specific order? Let me know. Is this a sequence? This yellow color, this is the sequence, yes or no? Okay, those who are saying yes, let me please explain why this is a sequence. Who is saying yes? Nadia told, yeah, Nadia, please let me know why this is the sequence. Why do you think this is sequence? What is the reason? Or what specific order they are following? 4 9 16 25. What specific order they are following? Let me know. What specific order is following? Because there in ascending there are square numbers. Yeah, that's absolutely correct. They are the square number. You can see if I write same thing, we can write like this: 2 square, right? Comma 3 square, comma 4 square, comma 5 square. Okay, like this. So it is actually following a specific order, right? It is following a specific order. So this is also a example of sequence. It is also a example of sequence. Then uh, this one also, next one, the 2 3 5 7 11, are there sequence? 2 5 2 3 5 7 11, this is a sequence. This one 2 3 5 7, is this a sequence? This is next one. Next one is not a sequence. This is not a sequence. Why do you think a sequence? Nadia, can you explain why do you think it is sequence? Just give me a reason. This is not a sequence. This is, I thought they were prime numbers arranged in ascending order. Sorry, I was stressing. Yeah, yeah, correct. They are the prime numbers. Okay, they are the first five prime numbers. Very good. They are the first five prime numbers. So I told that should be a some specific order, right? So they are the first five prime numbers. So it is also a sequence. Okay, is also sequence. So that is the things. Okay, then difference between what is a sequence and series. We sometimes we used to get confused between sequence and series. What is the difference between sequence and series? Sequence, I told that are the list of numbers or number they are on specific order. Okay, what is series? Series means when you add the values in a sequence together, then the sum is called series. Suppose in this last question you can see I took 3579, all this is the number from this sequence. Okay, so I am adding all the numbers, then this will be a series. This will be a series. 23579, when we are adding them, when we are adding them, then it will be a series. So when from a sequence we are adding the number, the values, then it is called series. So difference between sequence and series, I think it is clear, right? Now we have to learn that in sequence, sorry, in series there are two type of series. One is finite series. Finite means when we know the last term. Okay, it is called finite series. Okay, and the another one is infinite series. Finite sequence is um, like a1 a2 a3 up to an. We know when we know the last term, it is a number of, how many number of terms is there, we can see easily there are n number of terms is there, right? So this is called finite series. And what is infinite series? Infinite series is like this, when we don't know the last term, that is called infinite series. Okay, so when we last term is clear, I mean last term is given available, they're called infinite series. So sorry, finite series. And then when we don't know the last term and it's the terms can go to infinitely, then it is called infinite series. So now basically we need to introduce few things. I hope you all of you know this thing, this summation sign, summation notation. We just have to see, and summation means, suppose the big this one we are try to add first n terms. Okay, so we can write summation of a1 plus a2 plus a3 up to n in a this short form. This sign E like this, you can see this sigma like structure, it is called summation notation. Okay, so summation of a1 a2 an, we can, how we can express, we can directly write k equal to 1 in the bottom and top is 1. So k value is 1 to n and ak. What that mean? That mean when you putting k equal to 1, it will be a1, plus when you putting a k equal to 2, it will be a2. When you put a equal to 3, it will be a3, up until when you put a equal to n, it will be an. So this sign, sigma sign, that is denoting the summation. Okay, therefore example, let's suppose you have to find the sum of 1 2 3 4 up to 100. So this summation, how to find the summation? Summation will be this, that sigma I equal to 1 to 100. Okay, this 100 you can write down in top here like this. Okay, you should 100 can be written as up also, like this. Okay. Now, infinite series, how to find infinite series? So, infinite, I told that we don't know the last term. So, instead of n, we will write the infinite sign. Okay. So, that is the sequence and series first introduction. Let's go to the arithmetic progression. Though arithmetic progression is already deleted from your syllabus. Okay. Arithmetic progression is already deleted, but still we'll need to know some formulas. Okay. Otherwise, no use of. Okay. Arithmetic progression, you already learn arithmetic progression in class 10, right? Arithmetic progression, what is arithmetic progression? The arithmetic progression is a sequence is arithmetic progression if the difference between consecutive terms is constant, like 5, 7, 9. Okay, you can see all the numbers, the difference between 5 and 7 is 2, 7 and 9 is 2. So all this difference between any consecutive term is constant, then it is called sequence. Like um, here we try to write down as a note that a2 minus a1, that means the consecutive preceding term, succeeding term minus the preceding term, equal to, again here preceding succeeding term minus preceding term, that is equal to d. Okay, d is what? D in this common in the sequence a1, a2, a3, a4 are said to be ap if the common difference d is constant. You can say like this also. This is another type of um, what is called definition also, that if d is constant, then it is the arithmetic progression. Now to be arithmetic progression, here is the two few formula are there. First formula is nth term formula to find the nth term. Okay, and another is sum formula. In gp also we'll find same thing. In gp also we'll find the same thing. Okay, so nth term formula means general term or nth term formula, or last term also sometimes it's called. This formula means that n, suppose a is the first term and n is the number of terms and an is the last term and d is common difference. So the formula is an equal to a plus n minus 1 into d, or we can sometimes it is denoted with l also, last term. Okay, so where n nth term, l is equal last term, a equal to first term, like this. So maximum of you know this formula. Even the sum formula you learn in class 10, right? So sum of the first n terms of the AP is Sn n my equal to n by 2, where in the inside the bracket 2a plus n minus 1 into d, and Sn another formula is n by 2 a plus l. So where these things are given. So basically this part arithmetic progression is completely omitted from the for your final exam. Okay, so what we'll do, we'll directly go to the geometric progression, because arithmetic progression is not given, but you can still practice this arithmetic progression for few other what is called few other exam. Okay, so you can do the exercise, but we'll, for the exam purpose, we will go to the geometric progression. That is very important, and geometric progression question will come, that is included. Okay, so in geometric progression I'm just giving some example. One example is, yeah, first number you can see 5, 10, 20, 5, 10, 20, 40, 80. Okay, are they following any sequence? First number you can see, these numbers, are they following any sequence? If that, what numbers, what sequence they are following? A and B, you can see two things. A is written 5, 10, 20, 40, 80, and B is 10. Sorry, not B. Yeah, let me know. This 5, 10, 20, 40, is they following any sequence? Anyone? Is they following any sequence? Okay, still no response, but still from my side I'm saying, yeah, they are following any sequence. Why? Because look, every term is double, right? 5 into 2 is 10. Then 10 into 20, 10 into 2 is 20. 20 into 2 is 40. 40 into 2 is 80. That means the ratio, okay, ratio of consecutive terms is same. Look, 10 by 5, 20 by 10. Okay, the ratio, that means 40 by 20, 80 by 20. If you do like this, you will get always 2. So 5, 10, 20, 40, 80, they are following a GP. Why? Because geometric sequence is saying a sequence is geometric if ratio of consecutive terms is constant. That means you can see the succeeding terms divided by the preceding term is always constant. That is called geometric progression. Okay, a geometric sequence. So you can see I try to give one example where ar square, ar cube, ar to the power 4 all are following GP. Okay, because why? Because their the ratio of the consecutive term, look, a2 by a1. What is a2? Ar square by a. Okay, here it will be second term will be ar, not ar square. Yeah, second term ar square, then fourth term ar cube, like this. Always you will get the constant r. So geometric progression is saying when again another type of definition is the sequence a1, a2, a3, a4 are said to be geometric progression if common ratio r is constant. Okay, so now two things. First is general term, similarly same as GP, same as arithmetic progression. Here also we having um, some. Here also we having nth term or general term is usually known on some of the first n terms formula. So formula is this. First nth term formula. Nth term formula is this. Tn equal to a r to the power n. Okay, or Tn, instead of Tn we can say L also, the last term. Fine. The formula is a r to the power n minus 1. What is a? First term. R is common ratio, n is nth term. Last how many terms are there? Okay, not nth term, how many terms are there? Now the sum formula is two sum formula is there. Okay, there is two sum formula. Another first formula is Sn equal to a 1 minus r to the power n divided by 1 minus r when condition is r less than 1. R means common ratio. Okay, when we'll do the problem we'll see these things. And Sn equal to a r to the power n minus 1 divided by r minus 1 when r equal to 1 greater than 1. Why? Basically look, when r equal to r greater than 1, so r minus 1 will be always positive. And similarly, when r is negative, if I did 1 minus r, it will be always positive. Okay, so for that reason, we just write down this formula. Otherwise, you can use any formula, and similar, you can take common like this, you can do. Okay, no problem. But we'll follow this rule. When r common ratio, you can see that last time common ratio, what is the common ratio here? We got common ratio here 2. That means r is greater than 2, right? Sorry, r is greater than 1. So we'll use that time as in this formula, second formula. Now um, sum of infinite GP. Okay, sum of infinite GP means I told that there when there is no when there is no last term, that is called infinite, that the series which can go to infinitely, that is infinite series. So their formula is Sn equal to a divided by 1 minus r, where modulus of r less than 1. Okay, modulus of r less than 1. Let's do some problem, then we can understand. Okay, this formula will understand will between when we will do the problem. Okay, the geometric mean, this part I will do later. First, let me do some question. If you have the book, open page number 198. Geometric mean part I will do later. Okay, let's do some problem of exercise 9.3. This part I will do later. This part we'll do later. Okay, so exercise 9.3. Okay, first question number 1. Find the 20th term. Page number 198. If you have the book, please open. So question is saying, find the nth term of the GP. Find the 20th term and the nth term of the GP. GP, what is GP given? 5 by 2, 5 by 4 and 5 by 8. So how to do this problem? How to do? First we have to find the first term. What is the first term? First term is this one, right? So a r n, we have to look, our formula is this. Okay, our formula is this. So we have to basically find a r and n. So a is, we already got a 5 by 2. How to find the r? R means second term divided by first term. So second term is 5 by 4 divided by 5 by 2. So after cross multiplication, I mean like multiplication, we will get 1 by 2. So r value is 1 by 2. Then n equal to 20 and n equal to r. I mean sorry, n equal to 20 and n equal to n also. So first n equal to 20 using tn. Tn means t20. Okay, t20. So a r to the power n minus 1. So we just put it the value. You just check. We put it the value 5 by 2, r equal to 1 by 2 to the power 20. Here it will be 20 minus 1, right? 20 minus 1. So basically here it will be 2 to the power 19. Okay, so 2 to the power 19. Here also 2 to the power 19. So 2 to the power 19 and here 5 by 2. So denominator 2 is there. So in, if you add this one, I mean multiply this one, it will be 2 to the power 20. So basically we can write 5 into 2 to the power 20. That is the answer. Okay, or you can just keep like this also. We can just keep like this also. Similarly here also, I missed this one, n minus 1 things. n minus 1. Okay, here also 5 by 2, 1 by 2, to the power n minus 1. So basically here it will be, you can see here denominator 2 to the power n minus 1 here, and here 2 to the 2 is there. So 2 into 2 to the power n minus 1, it will be 2 to the power n minus 1 plus 1. So plus 1, first write down plus 1 here. 1 plus this one. So minus and n will cancel. So it will be 5 divided by 2 to the power n. Okay. We can keep like this also. 1 and minus 1 cancel. So that is the number 1. Next, number 2. Very easy. This geometric progression is very easy. You have to just, okay. Let's do question number 2. Question number 2. Question number 2 is, question number 2 is saying find the 12th term of the GP whose 8th term is 192 and common ratio is 2. So 8th term is given and we have to find 12th term. Only thing is given common ratio, right? So we have to write this here. R equal to 2. Okay. T 8 is given 192. Okay. We have to find the R. So what we have to find the 12th term. So what is the missing here? 12th term. So we can find that small n equal to 12. That's okay. But what is missing? Missing is first term, right? So we have to find the first term. From where we'll find from this T8 equal to 192, right? From here we'll find the first term. So you can write T8 equal to, then next line, T8 means a r to the power 8 minus 1, right? A r to the power 8 minus 1. You can see the formula. Formula is a r to the power n minus 1. So here 8 minus 1. From now it's okay. From next line, from next time I'll directly write a whenever T8, or you can see a r to the power 7. Okay, look, T8 means a r to the power 7. T11 means a r to the power 10, like this. Okay. Similarly, T10 will be a r to the power 9. So always the numerator will be 1 less. And we can put the value of r. Understand? We can put the value of r. What is the value of r? We know. Value of r we got 2 to the power 7, which is equal to 192. So a equal to 2 to the power 7 means 128, I guess. 2 to the 7 means 2 to the power 5 is 32. 64, yeah, 128. So therefore a equal to 192 divided by 128, which is equal to, or we can keep like this, better keep like this, a equal to, because next line we can cancel, 192 divided by 2 to the power 7. Yeah, keep like this. Okay. This 2 to the power 7, I'm just skipping down. So we have to find this. So T12 will be is equal to, anyone can tell me what will be T12 AR? What will be T12 AR to the power? What will be T12 AR to the power how much? AR to the power how much? T12. Fast reply. T12 equal to AR to the power. What will be the power of R? What will be the power of R? Fast reply me. What will be the power of R? Reply me. What is the power? Power will be R. R power will be. Let's see. Anyone replied? Yeah, 11. No. Here R will be 11. Okay. Hmm. So whenever this, I told that we'll directly write. Okay. T12 is equal to. Will not write A R to the power 12 minus 1. No need. Power will be always 1 less. So now A value will put the this. Will directly put this. Okay. Multiplied by R. R means 2 to the power 11. Right. Now you can see one thing. Next line I can write 192 into 2 to the power 11 divided by 2 to the power 7. Look, we can easily cancel now. So we can write 192 into 2 to the power, here equal to sign obviously. 192 equal to, it will be 2 to the power 4. So it will be equal to 192 into 2 to the power 4 how much? 416. So 192 into 16 how much? 3078. 3072. Okay, fine. Then next question. Question number 3. Question number 3. Very interesting question. Question number 3. Question number 3 is saying the fifth term, eighth term, and 11th term of a GP is PQRS. We have to show that Q square equal to PS. Okay, so let's do the solution. Okay, so what is saying? Fifth term, eighth term, 11th term is PQS, right? PQS or what? Yeah, PQS. So fifth term means T5, right? Similarly, eighth term is T8 and 11th term is T11. So whatever given, we just wrote. We have to write that let A be the first term and R be the common ratio. So T5 is equal to what we can write? Though I wrote like a breaking form, you can directly write A R to the power 4. Okay, T5 is equal to A R to the power 4. Understood? So T5 is equal to A R to the power 4, which is equal to P. Then T8 equal to a r to the power 7, which is equal to q, and T11, which is equal to a r to the power 10, which is s. Now left hand side q square is there, right? Q square means, what is q? Q means a r to the power 7. So just put the value a r to the power 7 square. So a square will be a square, and r to the power 7 and square. So it will be multiplied. So we'll left hand side we got a r to the power a square r to the power 14. On right hand side ps, just put the value of p and s. P value we got a r to the power 4. Look, and s value we got a r to the power 10. So a and a multiplied, so it will be a square, and r to the power 4 and r to the power 10 multiplied, so power will be added, so we are getting r to the power 14. So left hand side and right hand side equal, hence proof. Fine, very easy. These are very easy. Let's do few more problem. Then question number 4. Question number 4 is saying that the fourth term of a GP is a square of its second term, and first term is given -3. Okay, determine the seventh term. So what is given, let me show you. First, what is given? Given is fourth term, that means t4 is equal to square of second term. Second term is t square, sorry, t2. T2 is second term, so t4 is equal to t square. This is given. Okay, and given first term is -3. What we have to find? We have to find the t7. So here common ratio is not there, so here we'll find the common ratio. Sorry, we'll take the common ratio as r, right? Now t4 is equal to, we know that a r cube, a value we know -3, and r cube. So t4 we got -3 r cube. What is t2? ar, right, and -3 because of a. So t2 and t4 we got. We having this relation as per. So as per question we wrote t4 is equal to t2 square, where t4 put the value and t2 also put it the value. That means we got -3r whole square. Left hand side we got -3r cube, and right hand side we got -3r square. R whole square is 9r square. So if I divide both side with r square, left hand side I'll getting r cube by r square, and right hand side I'm getting 9 by -3. I'm just cross division. This side I'm dividing with r square, this r square coming down, and this -3 is coming this side. Okay, so basically here we are getting r equal to -3. So t7 value we have to find. T7 means a r to the power 6. Now we got a value is -3, r also -3. We just put it the value. Okay, then we are getting t is equal to -3 whole to the power 7. Now when the power is odd, minus will be remain same. Okay, so it will be -3 to the power 7, which is equal to -2187. That is the answer. So next, um, next next question is, we have to find which term of the following is sequence. Okay, for this one I'm doing question number 3. In your book, if you open the book, Okay, I'm doing the question number B. Fine. Question is, question is which term of this sequence is this? Okay, so basically you can see that this is the terms is given, right? So common ratio also we can find, last term also given. What you have to find? We have to find n, right? Which term of the following sequence is this? That means we have to find the n. So basically question number B I'm doing. Question number B, you can see that first term is root 3, second term is 3 root 3, like this it's going on. Then A means root 3. How to find the ratio? Ratio is second term divided by first term, A2 by A1. So 3 by root 3. So common ratio R we got 3, root 3. Okay. And nth term Tn is equal to 729. We have to find the n, right? So we are using the formula Tn is equal to A r to the power n minus 1. So just put the value Tn equal to 729. Then A equal to root 3 and R equal to root 3 to the power n minus 1. If you simplify, look, both base are same, so power will be added. So 1 plus n minus 1 and 1 cancel. Okay. Now 729, we just know that 729 is equal to 3 to the power 6. You can find by yourself also. 729 is equal to 3 to the power 6. And root 3. Root 3 here 1 cancel, so we got n only, power. Okay. So 3 to the power root 3 to the power n can be written as 3 to the power 2 n by 2. Why? Because we know that any square root of a can be written as a to the power 1 by 2. So square root of 3 to the power n can be written as 3 to the power n by 2. Fine. Then what? Both base are same from left hand side, right hand side. So their power will be equal. So n by 2 equal to 6, n equal to 12. Understood? This type of question is very important. In exam this kind of question is to come, very important problem. Okay, so basically you can understand that A and C will be homework. Fine. In question number 5, A and C will be the homework. Okay, next we'll do the last problem for today, question number 6. We'll do the last problem for today, question number 6. Okay, for what value of x these things minus 2 by 7, x and minus 7 by 2 are in GP. Can anyone tell me what is the condition to be a GP? When you can see one sequence is GP? Let me know anyone. When you can say one sequence is GP? When you can say a sequence is GP? Anyone please tell me. When you can say one sequence is GP? Any sequence is GP. When you can say? Or how, I mean, what is the condition to be a GP? if the consecutive, no, not consecutive term constant, if the common ratio is r, is the common ratio, yeah, when ratio is the same, so the ratio of consecutive term have to be constant. Okay, so what you have to do here, we have to check this term divided by this term is equal to this term equal to this term or not. That means second term divided by first term equal to third term divided by fourth term. Okay, this should be the sum. So we know a1, a2, a3 will be in GP if this thing, I'll just copy from there. If the second term divided by first term, second term divided by first term is equal to constant. Okay, constant. So basically they have to be equal. So what we have to do here, what we have to do, we have to check this x x divided by minus 2 by 7, okay, is equal to minus 7 by 2 divided by x. Okay, I'm writing like this so that you can understand properly. Then next line, so it will be x into minus 7 by 2, and here equal to minus 7 by 2 into 1 by x. Okay, so just simplify the next line. Next line simplify, it will be minus 7x by 2, and the right hand side we are getting minus 7 by 2x, right? Fine. So from both side minus minus cancel, okay. And from both side 2 also cancel, or we can directly write next line x square. I hope x square you can understand, this x and x is cross multiplied, right? So it will be x square, or you can directly write also 14x square, which is equal to 14. That means I just cross multiplied, minus minus obviously cancel, and then cross multiply. So x square is equal to 14 by 14, which is equal to 1. So what is the value of x? Value of x will be plus minus 1, right? We know that x square, x is equal to if x square equal to 1, x equal to plus minus 1. So but here one value of x will be accepted, either it will be plus 1 or minus 1. Can anyone tell me what will be the value of x? What will be the value of x, plus 1 or minus 1? What will be the value of x, plus 1 or minus 1? Anyone? What will be the value of x? We got x equal to plus minus 1, right? So x is plus 1 or minus 1? Fast reply. Okay, still no response. So I'm just saying this one, x will be both plus minus 1. Okay, x can be 1 also, plus 1 also, or it can be minus 1 also. Okay, So this is the thing. Fine, then today's class is up to this enough. So next day we'll discuss the sum also. Okay, so do this homework, do this homework, and now please write down your roll numbers, those who attended the class. Short